Okay, so we started with this probability. I gave the explanation to probability. We went ahead and solved some questions. We went to compound events. Then we are now moving to Quinn and Dye. Quinn and Dye experiments. What do we mean by Quinn and Dye experiments? What you want to say is that we can give you a question where more than one die is thrown or coin is tossed. Is that okay? We can also throw a die and a coin at the same time. So that's what you're going to look at. So first, you have to look at this example under this experiment. Two fair dice. So the plural form of a die is dice. A and B, each with faces numbered 1 to 6. So we all know that a die has 1 to 6 faces. Okay. Are thrown together. 1. Construct a table showing all the equally likely outcomes. From your table, list the pair of numbers on the two dice for which the sum is A, 5, B, 10, C, more than 10, D, at least 10. Find the probability that the two dice shows A, different scores, B, the same scores. Then find the probability that the sum of the numbers on the two dice is A, 5, B, more than 10, C, I think B is 10. Yes, B is 10. C is more than 10, then D is at least 10. So this is our first question that we are going to tackle it. Okay. Now, before I start solving the question, I want to show you something. We know that when a die is thrown once, the sample space is always 6. What of when we throw a die twice? What is going to be the sample space? What of when you do it 3 times or 4 times? What is going to be the sample space? These questions can be asked in objective. Is that okay? So for you to do that, we have a formula for it, for the die. So when I have this, is the formula for throwing a die. So that's 6 to the power n. 6 to the power n, okay? So when you throw the die once, then means that n is 1. So if I want to get the sample space, means that when I put n to be 1, so that will be 6, because 6 to the power 1 is 1. When the die is tossed twice, means I'm going to have my n to be 2. So I'm going to have s to be 6 to the power 2, so s is 36. So when we toss it 3 times, n is going to be 3, so that will be 6 to the power 3. Then you punch it in the calculator to get your answer. The same thing applies to the coin. You know the coin is head or a tail, 2 sides, right? So the sample space, if you want to get it, the formula is 2 to the power n. So when I toss it once, n will be 1 here, but I'll get 2 twice, I'll get 2 to the power 2, that will be 4. Is that okay? So when I toss it 3 times, you know what you're going to get, 2 to the power 3, which is 8. 4 times 2 to the power 4, which is 16. Is that okay? So take note of that. Now I also want you to know this. When I flip a coin 2 times, okay? When I flip a coin 2 times, 1 coin, and I flip it 2 times, the results or the sample space is also going to be the same as flipping 2 coins once. Flipping 2 coins once or tossing 2 coins once. Is that okay? Just like when I toss 1 coin 3 times, 1 coin 3 times, it's the same as tossing 3 coins once. And when it comes to the die, when I toss or throw a die, 1 die 4 times, is the same as throwing 4 dice 1 time. Okay, so now I have the table on the board. That's the area to construct the table. So the dice are A, then B. Is that okay? Or you can name it as A here, B here. It doesn't matter. So here, the first die, which is 1, 2, 3, 4, 5, 6. So the second die, you have 1, 2, 3, 4, 5, 6. So now when you toss, you can get 1, 1. Is that okay? So that is 1, 1. You can get 1, 2, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. So you can get 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 3. Oh, sorry. This will be 3, 1. So you're going to have 3, 1. Then you go to 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Then go to 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, then 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So I have my beautiful table, right? So you can see it. This is a very beautiful table. So now we're going to solve the questions or the subsequent questions that we have. Okay, so let's start with the II. The II said, from your table, list the pair of numbers on the two dice for which the sum is 5. So the first one, that's the A. Now you are going to do everything here. You want the one for which the sum is 5. So first one, the sum is A, 5. So first you want to get the one the sum is 5. Means that when I come here, if I take 1, 1, so 1 plus 1 is not up to 5. You see that 1 plus 2 is 3, it's not 5. 1 plus 3 is 4, it's not 5. So 1 plus 4 is 5. So that one will come here. So we are going to have 1, 4. Is that okay? So you can get 1 plus 5 is more than it. You know that. So this and that will also go. Then when I come here, definitely 2 plus 3 will give me 5. 2 plus 3 will give me 5. So I'm going to have 2, then 3. Then I'm going to also have, so this one is done. You can also pause the video and do it at your own pace, okay? Here when you come, you also have 3 plus 2 here. 3 and 2 here. Think after 3 and 2, there's nothing there again. Here I can have 4 and 1. So 4, 1. And I think so far 4, 1 here, that's all. That's all. So these are the sum of numbers. That will, or the sum that will give us what? 5. Now the B, or the B is also talking about 10. Right? The sum is going to give us 10. Let me check. Yes, 10. So let's look for 10. Those are the sum will give us 10. So in this case, this one 1 over 6. All of this side, the sum won't give us 10. Here too, the sum won't give us 10. Here, this will give us 9. This will give us 8, so it won't give us 10. So 4 and 6 will give us 10, right? Then when I come here, 5 and 5 will give us 10. 6 and 4 will give us 10. So these are the 3 numbers. Take 4 and 6. 5 and 5. And then 6, 4. So these are the 3 numbers that is going to give us 10. Maybe oversight, I didn't see any one of them. You can leave it in the comment section for me so that I can correct it. But for now, I think 4 and 6, 5 and 5. Okay, then 6 and 4. I think that's the only thing that will give us 10. So that is right. Now, we are done with that one. And the next one, they say that more than 10. More than 10. So those are the sum will give us more than 10. That's the C. So we want more than 10. So let's see. More than 10, you're going to have more than 10. So from here to here, yes, the highest is 9, right? So you can have 4, 5, that's 9. This is exactly 10, so that one is so. Here, this is 9, this is 10, okay. More than 10, so you can get 5 and 6. 6 and 5, then 6, 6. You can get 5 and 6, 6 and 5, then 6, 6. So I think these are the ones that are more than 10. The ones that are more than 10. Then we also move on to at least 10. At least 10. So at least 10, that's D. At least 10. So the difference between more than 10 and at least 10 is that the at least 10 is 10 or more. But more than 10, 10 is not part of it, okay? So we are going to have so those that are 10, that is 4, 6, 5, 5, 6, 4. That's at least 10. 5, 6, 6, 5, 6, 6. So at least 10 means 10 or more, but more than 10 is, you pick numbers that are more than 10, that's all. Is that okay? So this is the answer for the II. That's the answer. So let's move to the III. Okay, but before I clean this one, okay, let's write these ones down. A, that's sum of 5. We have 1, 2, 3, 4. We have 4 numbers. So the A, the number of sum of 5 is 4. Then let's count for the B. The B, we have 1, 2, 3, there are 3. Then C, that is more than 10. More than 10. That one is 1, 2, 3. That one too is 3. Then D, at least 10. 1, 2, 3, 4, 5, 6. You have 6. The D is 6. The reason why I'm writing this one down is that you will need it. These are the events of obtaining numbers of sum of 5, sum of 10, at least 10, more than 10. We will need them. So I don't want a situation whereby when we need it, we have to go back to the table. That's why I've written them down here. We are going to use it. So we are going to look at the next example. The subsequent question or the sub questions. The I said, find the probability that the two dice shown different scores. So I. We have to find it that it showed different scores. So we want to get that. We want to get the probability that it showed the different scores, right? The question is talking about probability. So the difference between the II and the III is that the II just talk about, you should just list them, okay? List them. That's why we just listed it. But the III is talking about probability. So you list them and you find the probability of it. So different scores here means that, you see, we have the same scores and we have different scores. The same score is when you get like 1, 1 is the same scores. 2, 2, the same score. 3, 3, the same score. 4, 4, the same scores. 5, 5, the same score. 6, 6, the same score. The remaining becomes a different score. Simple as that. So you can decide to list them or you just count them and pick your numbers. That's all. So here, if I start from here, the same scores will be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Okay. The remaining one, so from here, these are the same score. So we want the different score. So there's The remaining are the different scores. But remember, because you are talking about probability, first you need to get a sample space. These are 2 dice. So, as I said, the sample space will be 36. You can use the formula 6 to the power n. Okay? 6 to the power n. N is 2. So that's 6 squared. And that will be 36. Or you can decide to count it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 is 36. Okay? So, if I mean to list them in, it will be plenty. So what I'm going to do is I'll just count it. So let's forget about this first. So first, let's get the number of sample space. That's 36. Then you get number of getting different scores. And that will be, so getting the same scores is 1, 2, 3, 4, 5, 6. So when you take it from 36, that will be 30. Okay, so we want to get probability of getting different scores. And that is going to be the number of getting different scores over the number of what sample space. So getting different scores is 30. The sample space is 36. So that is all. You can reduce it. If it's possible that you can do it, you can do that. So 30 divided by 36, we have 5 over 6. 5 over 6. Is that okay? Simple as ABC. With the same II, the question said you should find the probability of getting the same scores. Okay. So, but this is I, but B. The first one was A. So, same scores. So first one, you have to find the number of sample space, which is 36. We have established that. And so it means that probability, you need to know your sample space. Then you also need to find the events or number of scoring the same or getting the same scores. And that one is how many? There are 6. 1, 2, 3, 4, 5, 6. So there are 6. So now if I want probability of getting the same scores, that is going to be number of event getting the same score, same scores over the number of sample space. So number of events of getting the same scores is what? Is 6. Sample space is 36. This will give us 1 over 6. Is that okay? Very good. So this is how it's done. So for the sample space, very important. You need to know it. Very important. Okay, now let's move to another sub question under it. The last sub one under it said, find the probability that the sum of the numbers on the 2 dice is 5. So first was, when you move to the I, it was, you have to list the pair of numbers on the 2 dice for which the sum is 5. By this time, we are not to list it, but we have to find a probability, okay? But already you have done this one in the II by listing them. So if you want to get the events or the number of the sum of 5, is very easy, right? So first one, the A said the sum of 5, probability of getting that. So, I think that's IVA. First thing, you want to get the sum of 5. But the probability of it, this time around, you are not listing it, you want the probability. So we need to know our sample space. Still 36, okay? Nothing changes, still 36, intact. Now, the event or the number of getting sum of 5 will be what? You did it, that is 4. You can just also still check, that is 1 plus 4, so this will be 5. So 1, 2, 3, 4, okay? So that will be 4. So now we want probability of getting sum of 5 will be number of getting sum of 5 over the number of sample space. So this gives us 4 over 36, and this will give us 1 over, think 9. 1 over 9. Okay, so now we move to IVB, sum of 10. Alright, you know the sample space to be 36, so we want sum of 10. Means that number of events obtaining sum of 10 is going to be, already done that, we had 3. You have 3. You can still check there. Those that when you add, you get 10. So 4 and 6, 5 and 5, then 6 and 4. That's the only numbers that when you add, you get 10. So meaning that if I want the probability of getting sum of 10, is going to be number of, or event of getting sum of 10, that is 3 over the sample space. Is that okay? So this one you can break it down. 3 can go into itself 1 and go into 36 12 times. So we are going to have 1 over 12. Is that okay? Good. Okay, so now let's move to the IVs. C, we have done with the A, that's sum of 5, and then you go to sum of 10. Now the C is probability of obtaining more than 10. So more than 10. More than 10. More than 10. So first thing, you know our sample space already to be 36. Then event of obtaining more than 10 will be what? More than 10, already I've done that. That is 3. You can still check numbers that are more than 10 when I add them. So that 5 and 6, that will give us 11. 6 and 5 also give us 11. Then 6, that will give us 12. The remaining will give us 10 or less. So we had only 3. So now I want to get the probability of obtaining the sum, more than 10. And that's going to give us 3 over 36. And that is still 1 over 12. 1 over 12. Then you also look at least 10. At least 10, right? So that's D for the IV. At least 10. So it means that event of obtaining at least 10 will be what? We have 6. That is 10 or more. So already you have established 6 and 4. That's this one plus this plus this. That's 3. This will give us 11. This will give us 11. This will give us 12. So if you combine those, that will give us 6 of them. So at least 10 will give us 6. So if you want to get the probability of obtaining at least 10, going to give us 6 over 36. That's 1 over 6. Okay. So these are the two or the answers to the question. I think it is so understandable. Please try to share to your colleagues, like and comment. Thank you. Let's move to example number 2. After the example number 2, I'll give a question for you to try and you test me the answer. Whether I leave it at the comment section, if you have my contact, you can test me directly. Thank you. Okay, so now let's look at the question 2. In a game, a player throws a die and tosses a coin. If the coin lands heads, he scores twice the number on the die. If the coin lands tails, he scores 3 times the number on the die. What is the probability of scoring more than 5? More than 5. So this is a question, a nice question. So let's see how we can look at questions like this. Okay, so first thing we need to draw a table. We need to draw a table. Okay, so now I have a nice table here. So this side is for the die and this side is for the coin. And per the question is saying that when the coin lands on the head, you score twice. When it lands on the tails, you score thrice or 3 times. So when it lands on the head, here is going to be what? 2 times 1, which is 2. 2 times 2, which is 4. So because when it lands on the head, you are scoring twice, okay? So here is going to be what? 6, 8, 10, 12. But when it lands on the tails, you are scoring 3 times or thrice. So that one you are going to get 3, 6, 9, 3, 4 is 12, 3, 5, 15, then 3, 6, 18. Please, I hope you understand this. The question said that when a player coin or when a die lands on the head, okay, you get twice of whatever that is getting. So twice means that you are multiplying that number that lands on the head by 2. So in case the one lands on the head, you get 2. Because 2 times 1 is 2. In case 2 lands on the head, that will be 2 times 2, you get 4. So that's what I'm talking about. The same thing applies to the tail. When the 10 lands on the tail, you score 3 times or thrice what is on the listing. So you are going to have, when the 10 lands, let's say 1 lands on the tail, you get 3, because 3 times 1. When let's say 4 lands on the tail, you get 12. Because 3 times 4 is 12. That's what we are talking about. Now the subsequent question says that, what is the probability of scoring more than 5? What is the probability of scoring more than 5? So that is 6 going, okay? So first you need to get a sample space. Sample space here, you simply count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They are 12. So that's our sample space. So our sample space is 12. Is that okay? Now you want getting a score of more than 5. So let's look for the event of scoring more than 5. So more than 5, let's see them. We have 6, 8, or let's list them first, right? So let me list getting more than 5. Getting more than 5. So you can have 6. The next number 8. You go to 9, because 9 is here, isn't it? From 9 you go to 10. You go to 12. You go to 15. The last one is 18. 6, 8, 9, 10, 12, 15, 18. So they are 1, 2, 3, 4, 5, 6, 7. They are 7. 1, 2, 3, 4, 5, 6, 7. They are 7. So here will give us 7. Good. So in this case, probability of getting more than 5 is going to be number of getting more than, that's the event, more than 5 over the number of sample space. So in this case, getting more than 5 is 7 over 12. So that is the answer to this beautiful question. I said that I'll leave a question there for you to try. Make sure you share, like, and subscribe. Thank you very much.